A giant glowing wheel made of pure blue light is floating completely alone in the deepest void of space. Inside that glowing wheel sits an empty gap of total blackness, 6 times wider than our entire Milky Way galaxy. Right at the dead center of that empty black ring sits a tiny, bright yellow ball of stars that should not exist according to every textbook ever written. This is not an illusion, and it is not an explosion frozen in time. If you love exploring the strange corners of our universe where real physics breaks every rule we thought we knew, tap that subscribe button right now. Join our community of curious minds as we unpack the deepest, most unbelievable true mysteries of space every single week. When you look up at the night sky through a backyard telescope, galaxies usually follow very strict rules. Nature likes order, and gravity usually builds things in predictable, organized shapes. For hundreds of years, astronomers believed they understood almost every kind of galaxy that could ever form in the cosmos. They cataloged millions of star systems across the universe, and almost every single one fit neatly into simple groups. Our own Milky Way is a classic example of what scientists call a barred spiral galaxy. It looks like a giant glowing pinwheel made of hundreds of billions of stars swirling gently around a supermassive black hole. Other galaxies are shaped like giant smooth footballs known as elliptical galaxies, packed with older reddish stars that have burned for eons. Then there are flat disk galaxies, and messy scattered clouds of stars called irregular galaxies. For generations, the famous astronomer Edwin Hubble organized these shapes into a visual chart called the Hubble tuning fork. It became the ultimate reference guide for astronomy, teaching every student that galaxies start out round and slowly flatten into beautiful spirals over billions of years. Everything in the cosmos seemed to obey these neat categories. Every star system found in the sky was expected to fit into one of these standard cosmic boxes. Then, on a quiet night in 1950, an astronomer named Arthur Hoag pointed a powerful telescope toward the constellation Serpens Caput. He was studying faint patches of light located roughly 600 million light-years away from Earth. 600 million light-years means the light reaching his camera lens left those stars when simple life on Earth was just beginning to crawl out of ancient oceans. What Arthur Hoag saw through his telescope lens stunned him so completely that he thought his equipment was broken or dirty. Centered in the viewfinder was a nearly perfect glowing circle of brilliant blue stars, completely detached from anything else around it. The ring measured an incredible 120,000 light-years across, making it slightly larger than our entire home galaxy. Inside this giant glowing blue ring was a massive gap of pure, empty darkness that stretched for 70,000 light-years. If you were standing on a planet inside that gap, you would look up and see a night sky completely devoid of stars in every direction. And sitting directly in the middle of that vast emptiness was a completely separate, perfectly round ball of ancient yellow stars. At first, Arthur Hoag assumed he was looking at a planetary nebula, which is a shell of glowing gas puffed out by a single dying star. That was the most logical guess, because planetary nebulae often look like round smoke rings in small telescopes. But when other scientists calculated the true distance, the math proved that explanation was completely impossible. This was not a cloud of gas from a single dying star. It was a colossal structure containing tens of billions of full-size suns. Scientists then wondered if they were looking at a famous optical illusion predicted by Albert Einstein called an Einstein ring. Einstein showed that when a huge mass sits directly between Earth and a distant object, its gravity bends the background light like a giant magnifying glass. If a bright galaxy sat directly behind a massive cluster, its light would get smeared into a perfect glowing circle in our telescopes. For years, researchers debated whether this mysterious circle was just a trick of bent light playing games with our instruments. But as telescope technology improved, astronomers measured the speed of the stars in the blue ring and compared them to the yellow core. Both parts were moving through space at the exact same speed and located at the exact same distance. That proved beyond any doubt that the ring and the core were physically connected parts of the same single object, now known as Hoag's object. Have you ever seen an image of Hoag's object before? Or is this your very first time hearing about this impossible cosmic wheel? Drop a comment below with your first impression, and hit the like button if you find space mysteries as thrilling as we do. To understand why Hoag's object broke every rule in astronomy, you have to look at the huge contrast between its two main parts. The central core is packed with very old, quiet stars that glow with a warm, reddish-yellow light. These stars are billions of years old and have almost no gas left between them, meaning the core has completely stopped making new stars. It behaves just like a miniature elliptical galaxy that finished growing eons ago. The outer ring, on the other hand, tells a completely opposite story. That giant 70,000 light-year wide circle is glowing bright electric blue because it is overflowing with newborn supermassive stars. These young stars are burning through their nuclear fuel at unbelievable speeds, shining fiercely and lighting up the ring like a neon sign. Where did all the cold, gas, and dust come from to ignite this sudden burst of starbirth in a perfect ring? In normal spiral galaxies, gravity uses invisible waves to sweep gas into winding spiral arms, which triggers star formation in long trails. But in Hoag's object, there are 0 spiral arms, 0 bars of stars across the center, and 0 physical bridges connecting the core to the outer wheel. The ring floats in complete isolation, orbiting the quiet yellow center across a vast sea of empty space. Astronomers initially proposed that a direct collision must have created this strange shape. In computer models, when a smaller galaxy punches straight through the middle of a larger spiral galaxy like a bullet, it creates a powerful shockwave. That shockwave ripples outward through the gas disk like a stone dropped into a calm pond, compressing the gas and igniting a ring of new stars. We have seen this happen elsewhere in the cosmos, such as the famous Cartwheel Galaxy located 500 million light-years away. In the Cartwheel Galaxy, you can clearly see the messy aftermath of the crash, including long streams of displaced gas and the runaway bullet galaxy speeding away in the distance. When galaxies collide, they leave behind huge scars and visible debris trails that last for hundreds of millions of years. Here is the mystery that makes Hoag's object so baffling. There is no scar, no debris, and no bullet galaxy anywhere nearby. When astronomers scanned the surrounding space with deep radio telescopes, they found the environment completely calm and empty. If a high-speed collision had happened, the intruder galaxy should still be visible nearby, yet space around Hoag's object is entirely vacant. Even more shocking is how perfectly round and symmetrical Hoag's object is. Violent collisions leave behind twisted, warped, and uneven shapes because cosmic impacts are messy and chaotic. Yet the blue ring of Hoag's object is almost a mathematically perfect circle, with uniform thickness all the way around. It looks as smooth and balanced as if someone drew it with a compass on a blank sheet of paper. This led theorists to suggest a completely different idea called galaxy cannibalism. Perhaps billions of years ago, the central core slowly swallowed a smaller, gas-rich neighbor that got too close. If the core tore the smaller galaxy apart with gentle tidal forces over a very long time, the stolen gas might have spread out into a stable orbiting ring. If that sounds like a tidy answer, the math behind it creates an even bigger problem. For a shredded galaxy to settle into such a perfectly circular, stable ring without disturbing the central core would require conditions so precise they seem almost impossible. The incoming galaxy would need to approach at the exact right angle, the exact right speed, and with the exact right mass. If it were even slightly too fast or too heavy, the entire structure would have been torn apart into a messy cloud. What makes this cosmic puzzle even more mind-bending is a tiny detail hidden directly behind Hoag's object. When the Hubble Space Telescope took an ultra-deep, high-resolution photograph of the galaxy in 2001, scientists zoomed into the empty black gap between the core and the ring. Looking at the 1 o'clock position in that dark gap, they spotted something that made their jaws drop. Floating millions of light-years in the background was another ring galaxy, identical in shape to Hoag's object, perfectly framed inside the gap of the first one. It was another yellow core, surrounded by an empty void and a glowing blue ring, sitting far deeper in the distant universe. The odds of finding 2 of the rarest galaxy shapes in the universe, aligned perfectly in the same line of sight, are practically 0. Do you think ring galaxies are formed by freak collisions? Or could there be a secret law of physics creating these cosmic rings that we have not discovered yet? Let us know what you think in the comments, and take a quick second to share this video with a friend who loves cosmic puzzles. For decades, many astronomers believed that Hoag's object was just a one-of-a-kind freak accident of nature. They called it a Hoag-type galaxy and assumed we would probably never find anything quite like it ever again. Because ring galaxies make up less than 0.1% of all known galaxies, finding another one with unique properties seemed like finding a needle in a cosmic haystack. That all changed in 2017 when an astrophysicist named Burcin was studying a faint galaxy catalogued as PGC 1007-4. Located roughly 359 million light-years away in the southern constellation crater, this galaxy looked like a standard Hoag-type ring galaxy at first glance. It had a well-defined elliptical core and a bright, star-forming outer ring orbiting in clear isolation. Dr. Mutlu and her research team collected deep photometric data using powerful telescopes in Chile to analyze the colors and ages of the stars. They wanted to measure the exact brightness profile of the galaxy to understand how its outer ring had developed over time. To do this, they used specialized computer software to subtract the light of the central core and the outer ring so they could inspect the faint background. When they removed the bright light of the outer blue ring, something completely unexpected appeared on their computer screens. Hidden inside the dark gap between the core and the outer ring was a second, completely separate inner ring of stars. Nobody had ever seen a galaxy with two distinct rings that were completely detached from each other in the central core. Even more incredible was the age difference between the different parts of this newly discovered system, which quickly became nicknamed Burcin's Galaxy. The central core was estimated to be around 5.5 billion years old, glowing with red and yellow light. The outer ring was packed with young, brilliant blue stars that were only about 0.13 billion years old, meaning it had formed very recently in cosmic history. The hidden inner ring was different from both of them. It was made of much older, reddish stars that had formed billions of years before the outer blue ring ever existed. This meant that Burcin's galaxy had not experienced just one mysterious ring-forming event. It had gone through two completely separate ring creation events separated by billions of years. Scientists found themselves completely unable to explain how a single galaxy could build two separate rings at two different times without destroying itself. In normal galaxy evolution, any event violent enough to deliver a fresh ring of gas should easily disrupt or tear apart an older, delicate ring already orbiting inside. Yet here sat two concentric rings, floating peacefully around the same central core like ripples frozen in time. The discovery of Burcin's galaxy proved that Hoag's object was not just an isolated freak event. Instead, it showed that under the right conditions, the universe can repeatedly build nested circular star systems that defy our standard computer simulations. The discovery forced astrophysicists to go back to their drawing boards and rethink the basic mechanisms of how galaxies capture matter. One leading theory suggests that these galaxies might be feeding directly on the invisible cosmic web. Space is not completely empty. It is threaded with long, gigantic filaments of cold hydrogen gas connecting vast clusters of galaxies. If a quiet, elliptical galaxy drifts along one of these filaments at just the right speed, it might slowly siphon gas from the filament into a stable, orbiting ring, without ever colliding with another galaxy. This process, known as cold gas accretion, would allow a galaxy to quietly build a brand new ring of baby stars over billions of years. Because the gas falls in smoothly and steadily from the surrounding environment, it does not create the violent shockwaves and messy scars of a direct crash. It acts more like a gentle cosmic sprinkler, slowly feeding fresh fuel into an orbiting circle until gravity pulls the gas together to ignite new suns. If you had the chance to name a newly discovered galaxy, what kind of name would you pick for something this strange? Tell us your best ideas down in the comments, and make sure to subscribe so you never miss another deep dive into the unexplained wonders of our cosmos. While ring galaxies challenge our understanding of symmetry, the universe also builds galaxies shaped like terrifying, chaotic monsters. Take, for instance, the cosmic anomalies known as Jellyfish Galaxies, drifting through massive galaxy clusters hundreds of millions of light years from Earth. These bizarre systems look like glowing ocean creatures trailing long, bioluminescent tentacles through the dark sea of space. A prime example is the galaxy designated JO206, which is plunging headfirst into a dense ocean of superheated gas inside a giant galaxy cluster. As the galaxy speeds through this hot cluster medium at millions of miles per hour, it experiences a powerful force called ram pressure stripping. It is the exact same effect you feel when you stick your hand out of a car window on the highway and feel the rushing wind pushing against your palm. This cosmic wind is so intense that it literally rips the cold gas and dust right out of the galaxy's body. The stripped material gets pulled backward into massive glowing tentacles that stretch for hundreds of thousands of light years behind the galaxy. Inside these long trailing tentacles, something incredible happens. The stolen gas compresses and ignites, giving birth to brand new stars floating completely outside the parent galaxy. When astronomers look at JO206 through powerful space telescopes, they see newborn star clusters forming in long, straight lines trailing behind the dying core. It is a striking visual reminder that galaxy evolution is often violent, dynamic, and capable of creating shapes that look more like living organisms than rigid physical machines. The galaxy is effectively bleeding stars into the intergalactic void as it races toward its eventual doom. Another mind-bending structure is the famous cosmic seagull, catalogued as NGC 6744, and the strange system known as the Tadpole Galaxy, or UGC 1024. Located 420 million light-years away in the constellation Draco, the Tadpole Galaxy features a massive, brilliant spiral body attached to a colossal tail of stars. This straight, glowing tail stretches for an astonishing 280,000 light-years across deep space. That tail is more than twice the length of our entire Milky Way galaxy, packed with millions of bright blue infant stars and giant clusters. It was formed when a tiny, compact intruder galaxy crossed paths with the main galaxy, using its intense gravity to sling a massive stream of stars out into space. Eventually, computer models show that this giant tail will break apart into dozens of miniature dwarf galaxies that will orbit the main remnant forever. Then there are galaxies that look like pure geometric questions written across the fabric of the universe. In recent years, deep field observations from the James Webb Space Telescope have revealed bizarre structures that resemble question marks, glowing arcs, and interconnected knots of light. In one famous deep field image, two merging galaxies located billions of light years away, aligned in such a way that they formed a literal cosmic question mark, glowing in infrared light. These discoveries are showing us that our classic picture of neat, orderly galaxies was deeply incomplete. The universe is far more chaotic, creative, and unpredictable than early astronomers ever dared to dream. Every time we build a larger mirror and point it deeper into the dark, we find objects that shatter our textbooks and demand new explanations. Did you know that galaxies could leave giant trails of newborn stars behind them like glowing tentacles? Or did this fact blow your mind today? Leave a thumbs up if you are learning something brand new, and let us know your favorite cosmic anomaly in the comments section below. To truly understand why these bizarre shapes matter so much to modern science, we have to look at the invisible ghost that controls the entire cosmos: dark matter. Dark matter is mysterious, invisible stuff that makes up roughly 85% of all the matter in the universe. It does not emit light, reflect light, or absorb light, making it completely invisible to every telescope ever built. Even though we cannot see dark matter directly, we know it is there because of its immense gravitational pull on normal matter like stars and gas. Every galaxy we know of is believed to sit inside a giant invisible sphere of dark matter called a dark matter halo. This invisible halo acts like a gravitational scaffold, holding the galaxy together and preventing its fast-moving stars from flying off into deep space. In normal spiral and elliptical galaxies, the dark matter halo is shaped like a smooth, round ball or a slightly flattened egg. This smooth distribution of invisible mass is what allows spiral arms to maintain their graceful shapes and keep stars orbiting in steady, predictable paths. If you change the shape of the dark matter halo, you completely change how the stars and gas inside that galaxy are allowed to move. This brings us right back to the central mystery of Hoag's object and Burcin's galaxy. For a galaxy to maintain a perfectly stable, isolated ring over billions of years, its invisible dark matter halo must have a very specific, unusual configuration. Some astrophysicists now believe that the dark matter surrounding Hoag's object might not be a simple round ball at all, but a complex hollow structure that acts like a gravitational mold. If the dark matter halo itself has a flat or ring-like shape, it could trap incoming gas in a circular gravitational valley. The gas would naturally settle into that invisible groove, creating a ring of high density where stars could ignite and burn for millions of years. In this view, the glowing blue ring of Hoag's object is not an accident of nature. It is a visible blueprint of an invisible dark matter structure that we cannot otherwise see. Understanding these peculiar galaxies might be our best shot at solving the mystery of dark matter once and for all. If standard computer models of galaxy formation cannot reproduce a stable ring galaxy without fine-tuning their dark matter parameters, then our core theories about dark matter might need an overhaul. These rare, rule-breaking galaxies are serving as high-stakes laboratories testing the fundamental laws of gravity. Consider what happens inside the central, supermassive black hole of such a ring galaxy. In ordinary galaxies, continuous streams of gas spiral inward toward the galactic nucleus, constantly feeding the central black hole and sparking powerful jets of radiation. But inside Hoag's object, that central feeding supply was severed billions of years ago when the inner disk cleared out. The supermassive black hole at the center of Hoag's object is essentially sleeping in absolute starvation. Without gas clouds falling into its gravitational grasp, it remains quiet and dark, producing no blinding quasar flares or high-energy gamma-ray beams. It sits in the middle of that ancient yellow stellar ball like a silent titan surrounded by an empty desert of space. Meanwhile, 70,000 light-years away across that desert, the outer blue ring is alive with catastrophic stellar explosions. Massive blue stars live fast and die young, burning through their hydrogen fuel in only a few tens of millions of years before detonating as violent supernovae. In that glowing outer wheel, giant stars are exploding on a regular cosmic schedule, blasting heavy elements into the ring to seed future generations of planets. When we study these exploding stars, we realize that the chemical makeup of the ring is evolving very differently from the central core. The core ran out of star-making materials billions of years ago, freezing its chemical recipe in time like an ancient fossil. But out in the blue ring, each exploding supernova enriches the gas with heavy elements like carbon, oxygen, iron, and gold. This means any rocky planets forming in the outer ring today are being built with rich mineral ingredients that never existed in the core. If you could land a robotic rover on an alien world inside that glowing wheel, its rocks would be packed with exotic metals forged in rapid generational cycles. It is a striking reminder that one single galaxy can host two completely different geological eras at the exact same moment. If an advanced alien civilization lived on a planet orbiting a star inside that outer blue ring, their view of the night sky would be unlike anything humans have ever seen. Half of their sky would be dominated by an immense, dazzling wall of bright blue stars and glowing emission nebulae stretching across the horizon. The other half of their sky would look into the pitch-black void, with only the distant, eerie yellow sphere of the central core glowing like a lonely lantern in the dark. They would look across 70,000 light-years of absolute nothingness to see an ancient, frozen relic of a galaxy sitting at their center. Their astronomers would look outward into deep space and wonder why their world was trapped inside a giant spinning wheel of fire, while the rest of the universe was filled with spirals and pinwheels. They would face the exact same mystery that Arthur Hoag faced when he first pointed his telescope at the sky in 1950. How long can such a delicate structure survive before the laws of gravity inevitably tear it apart? Standard astrophysics tells us that isolated rings of gas and stars are inherently unstable over cosmic timescales. Small gravitational perturbations from passing dwarf galaxies or internal density waves should eventually cause the ring to warp, buckle, or collapse inward toward the central core. Yet precise computer simulations show that if the dark matter halo is massive enough, it can act as a stabilizing gyroscopic anchor. The dark matter can keep the ring spinning smoothly for tens of billions of years, far longer than the current age of our universe. That means Hoag's object might not be a temporary snapshot of a fading collision, but one of the most long-lived and stable structures in the entire cosmos. What if there are hundreds of these ring systems hidden even further away, dating back to the very dawn of time? When the James Webb Space Telescope looks back more than 13 billion years into cosmic dawn, it is finding mature, highly structured galaxies that should not have had time to form according to our old models. The early universe was far more efficient at assembling giant star systems than anyone thought possible. Could ring galaxies have been among the very first complex structures built after the Big Bang? If primordial gas clouds in the early universe possessed high angular momentum, they might have naturally collapsed into giant spinning rings around dense central knots. If that is true, Hoag's object in Burcin's galaxy might be living cosmic fossils, preserved relics of an ancient era when the universe was building star systems using rules we have forgotten. Think about the sheer scale of the distances involved when we study these deep space anomalies. When we look at light that has traveled for 600 million years, we are not looking at Hoag's object as it exists today. We are looking at a historical recording carried across the vacuum of space by ancient photons. In the 600 million years that have passed since that light began its journey toward Earth, the blue ring has made several full rotations. Millions of massive blue stars in that ring have already exploded into supernovae, their remnants collapsing into stellar mass black holes and neutron stars. New generations of stars have ignited from the enriched debris, continuing the cycle of stellar life and death inside that isolated circular cradle. What does Hoag's object look like right now in the present moment? We will have to wait another 600 million years for that light to arrive on Earth to find out. Would you dare to travel across 70,000 light years of pure pitch-black space just to stand on a planet inside that glowing blue ring? Drop your answer in the comments right now and hit that subscribe button to keep uncovering the craziest truths about our universe with us. Right now, astronomers around the world are preparing massive new surveys using next-generation observatories like the Vera C. Rubin Observatory in Chile and the Nancy Grace Roman Space Telescope. These advanced instruments will photograph billions of galaxies across the entire visible sky, mapping their shapes, colors, and motions with unprecedented clarity and speed. Astronomers predict that these upcoming surveys will discover hundreds of new ring galaxies and previously unseen cosmic shapes hidden in the deep sky. By analyzing large populations of these rare objects, researchers will finally be able to run statistical tests and run thousands of new supercomputer simulations. We will finally find out if Hoag's object is the result of quiet gas accretion, freak collisions, or an undiscovered property of gravity itself. The mystery of galaxy shapes is not just an abstract puzzle happening millions of light years away. It is also the direct story of our own future. Right now, our Milky Way is traveling through space at over 1 million miles per hour on a direct collision course with our nearest giant neighbor, the Andromeda Galaxy. In about 4 to 5 billion years, these two colossal star systems will slam into each other in a magnificent cosmic dance. During that future collision, the graceful spiral arms of both galaxies will be violently ripped apart by immense gravitational forces. Vast tails of stars, stretching across hundreds of thousands of light years, will be flung out into the void, temporarily transforming our home into a chaotic, tangled mess of glowing gas. The night sky of any future Earth will look completely unrecognizable, lit up by colliding star clouds and ferocious bursts of new starbirth. Eventually, over hundreds of millions of years, the two giant galaxies will settle down and merge into a single massive elliptical galaxy that scientists have already nicknamed Milkdromeda. The spiral shape that has defined our cosmic home for over 10 billion years will be completely erased, replaced by a smooth, quiet ball of ancient stars. The very same physical laws that sculpted the Tadpole Galaxy, the Jellyfish Galaxies, and perhaps even Hoag's object will rewrite the structure of our own home. When you step outside tonight and look up at the dark sky, remember that the universe is not a static painting frozen in time. It is an ever-changing, dynamic canvas where galaxies are constantly born, torn apart, reshaped, and rebuilt across billions of years. Objects like Hoag's object remind us how small our current understanding really is and how much incredible wonder remains out there waiting to be found. If this deep journey into the weirdest shapes in our universe sparked your imagination today, make sure to hit the subscribe button right now and turn on all notifications so you never miss an episode. Drop a comment below answering our big question. Do you think our own Milky Way will leave behind an extraordinary shape when it merges with Andromeda, or will it blend into a normal sphere? Share this video with a fellow astronomy lover, and thank you so much for watching.